So this is the continuation part of my previous video. So here we have talked about the tolerance limit. So if I take the zeta value very less than 1, I am going to discuss about the conditions of zeta and the different names of those conditions. But now take it for granted and do the calculation and derive the formula of Ts. So e to the power minus zeta omega in Ts is equal to 0.0 because it will be 1 and root over 1 is 1. Now taking ln in both sides, we are getting this. For the minus term, if I take it here, ln into 1 by 0.02. I am repeating it once again. If I take this whole term in the right side, 1 by zeta omega n, and minus term will be there. If I take it inside the ln, it will be 1 by 0.02, that will be 50. If I take the ln 50, it will be near about 4. You can calculate it in the calculator. So the final Ts value will be 4 by zeta omega n, and 1 by zeta omega n, this term is actually represented by tau. Tau is actually the time constant. It is actually the time constant of this second order system. This is a very frequently asked question in MCQs also. That is directly 4 tau will be given and we just have to tick the answer. So the 4 derivations are done. The most important thing is you have to remember the direct formulas. From the direct formulas it is basically comes. So I have done the derivations only for the understanding sake. So you just have to understand things and then you have to remember the things. Now I am taking the zeta value in consideration and taking all the conditions of zeta. How many conditions can come? Let us see. Now taking the response formula Ct, we just have to calculate the different cases. So there are actually 4 cases. Case 1, taking zeta is equal to 0. This condition is actually called undamped condition. The name of this condition is undamped condition. Means the damping factor zeta value is 0, hence this is called undamped condition. In that case, the transfer function, if I replace the value of zeta in the transfer function will be omega n square by ac square plus omega n square. In this case, the poles will be s is equal to plus minus j omega n. From here, from the denominator part, if I replace it with like characteristic equation, we will find s is equal to minus plus minus j omega n. That is actually the value of poles. So in that case, in undamped case, it will be not damped, so the response will continue like this, means it will be never stable. This is the undamped condition. Now case 2. Case 2 is taking the zeta value less than 1. Previously I have told you zeta is very less than 1. This is nothing but this condition. This condition is called underdamped condition. Underdamped. In this case, transfer function is equal to omega n square by ac square plus 2. Zeta is actually 1, so omega n is plus omega n square. From here we can find the poles value. S is equal to minus zeta omega n plus minus j omega d. In that case, the response will be the response we normally take. Previously discussed response value. The third case, that is case 3. Here we are taking zeta is equal to 1. Right? Zeta is equal to 1. This one has an interesting name. This is called critically damped. Critically damped condition. Critically damped. In this case, transfer function is nothing but omega n square by s plus omega n the whole square. In this case, like we can take any value. We can take zeta here. With zeta it is calculated, but in this case there is no zeta, only one, so we can take the. So here in critically damped case, transfer function will be omega n square by s plus omega n square. From here we can see s is equal to minus omega n and one another value, that is also minus omega n square. Very important. Must remember this condition. In this case, if I take the CS, the response, that will be represented by 1 by s plus b by s plus omega n plus c by s plus omega n the whole square. Like this, if I substitute, like if I now find out the response values, it will be directly come 1 by e to the power minus omega n t minus omega n t e to the power minus omega n t. The derivation part is not important. This is also not that much important. Just you have to understand what is happening with the pole values, and the response will finally, if I plot this will be coming like this. This is the most important. Remember the plot value. Now the last case and fourth case, that is zeta greater than 1, that is called over damped condition. In this case, the transfer function will be obviously omega n square by s square plus 2. Like I can take it zeta and also I can take it rho. I am taking zeta omega ns plus omega n square. In this case, the value of s will be minus zeta omega n, the same as previously zeta less than omega n condition. But in this case, that inside the root over, it will be zeta square minus 1, as it is greater than 1. This part is very important. Always remember this. In this case, the response part will quite look like this. Just remember that this is enough for your exam. Now if I plot all the zeta values and corresponding response for the pole values in S plane, means here it will be sigma, here it will be j omega n. The plot will look like this. When zeta is 1, we'll get poles at here. Zeta is equal to 1 at minus omega n. There will be 2 poles in the same point, right? When so now there are 2 poles at the location of omega n. I have told you that when zeta is equal to 1 means this one, when zeta is equal to 1, transfer function is this one, and we'll get the poles at minus omega n and also another pole at minus omega n, means two poles at the same location. So like this, for different values of zeta, I am plotting the poles, right? So two poles are at minus omega n. Let us see. Here are the two poles at minus omega n location. This is minus omega n actually. Minus omega n location. And this is the plot of actually j omega n, means the complex part of the complex part versus the real part of S plane. S is equal to sigma plus j omega. So for the values of sigma, zeta is equal to 1, two poles are at minus omega n, and as we decrease the omega, as we decrease the zeta value, the damping factor value, we have seen that there are two poles. One is at j omega n, okay, and another one is at minus j omega n. You have previously seen that here when the zeta value is 0 means zeta value is reducing from 1 to 0, then the value is plus minus j omega n. Now we have seen two plotting, one is for zeta is equal to 0, another one is for zeta is equal to 1. But when it is reducing, zeta is less than 1, the pole location is this one. So as the zeta value is reducing, the real part value is reducing, means the plot will be something like this. So if I decrease the zeta value from here, actually zeta is equal to 0, we will get here zeta value is equal to, I am doing it with another color, here zeta is equal to 1, here zeta is equal to 0. But when we are reducing the zeta value from 1 to 0, the real part value will be decreasing, right, in both the cases. So as the zeta value is increasing, there is also the real part value is increasing. So we can make the direction like this, and after that when we are increasing the zeta value, zeta is greater than 1, this path is for 0 less than zeta less than 1, same for this one. But when we are increasing the zeta value, we will see that it will be on real axis, means this will be the path that is for zeta greater than 1. So this is actually the plot of complex part versus the real part on S plane. And here we are actually taking the third variable as zeta. So this is nothing but the root locus plotting. This is actually the root locus of the second order system, where we are varying the zeta value as the third variable, and this is the plot of it. So root locus you don't know now. This is actually a very important plot for your exam. Directly it is asked after you can understand the basic how it is plot now, but what is root locus you will understand later when I'll discuss it later. So this is the upcoming videos. So just for now, you just understand this plot and remember it. So now this is the final part of the video. Here I am discussing the overall response plot, where I have drawn all the responses according to the zeta values. So here is the CT versus time, matlab the response versus time plot, where the first one in black color, that is for undamped condition, means the zeta is equal to 0. The red one when zeta is less than 1, that is called underdamped condition. So the plot is like this. For overdamped condition, the plot was like this, means it was very quickly getting the steady state value, means 1, as we are feeding the step input, so it is giving the step response, that is it is acquiring the value of 1, and the zeta is equal to 1, that is critically damped condition. We have discussed this plot before, but I am taking the overall plot. It will be very helpful to understand or relate, or for the relative discussion. So this is the final part of the video. So thank you for watching the video. If you like it, please subscribe my channel and share with your friends. In my next videos I am going to discuss about the steady state error, that is one more parameter of the time domain response analysis of second order system or any type of system. There can be several type 0, type 1, type 2, type 3. So for that systems I will be discussing the steady state error. Thank you.